Before we get into the different ways to authenticate, let's start by laying the groundwork. We'll first explain what authentication really means, then go over who's involved in the process. We'll also look at how usability comes into play and discuss differences between customer and employee authentication. Our discussion will focus on a scenario you're likely familiar with: a person logging into a remote server. For example, when you log into your favorite social media platform. Let's start with authentication. Have you ever gotten a call from an unknown number and wondered if it might be a scam? Let's look at this example. Maybe it's someone claiming your tax return is invalid, urging you to send money right away to avoid legal trouble. Or it could simply be a friend calling from their new work phone. Let's answer this call. Hello, who's there? A person on the other end says, "Hello, I'm John Awesome, calling from Legit Corporation." Now you think you know who's calling, but do you really? What you actually know is the identity that's been claimed. There's no evidence yet that it's true. Technically, what just happened was an identification process, answering the question, who is this? In the digital world, you see this when you provide your username, email address, or phone number to a system to locate your record. Returning to our phone call example, you start to feel something's off. Even though you are a customer of Legit Corporation, you want to be sure it's a legitimate employee on the other end. But how can you verify this? Well, you can ask them something that only you and a real Legit Corporation employee would know. For example, what was the amount of my last month's invoice? If it's a legitimate call, they should be able to answer. For example, your invoice was $23. Once they answer correctly, you can feel more confident that you're talking to a real employee. This is an example of knowledge-based authentication. It's not the most secure method, but it's still used in some cases. Authentication, in essence, verifies whether the claimed identity belongs to the person who's presenting it. In the digital world, you might recognize forms of authentication like passwords or push notifications. We'll explore these in more detail later in the course. For now, let's take a look at the typical authentication parties. You likely use multiple methods to access your data and services. Whether it's a web browser on your PC or an app on your mobile device, both typically interact with service providers operating over the internet. For instance, when you open your favorite social media app, requests like "show me the latest news feed" are sent to the provider's server. This setup is a common model called client-server. Your app or browser acts as the client, and the provider's service is the server. The client makes various requests to the server, which then provides content for the client to display. Some data, like recent public comments, can be accessed by any client, but personal information created and collected about you typically isn't public. Most services require you to create an account that represents your identity within the system and to register an authentication method. Whether it's a password or an SMS OTP, the server needs to collect some information about you to verify your identity later. You might ask, why is this important? Are there other models? Yes, there are. For example, two servers can communicate with and authenticate each other. But in this course, we're focusing on the client-server model. What about the type of client used for authentication? Does it matter? You might think it doesn't, especially with password-based authentication, but as you'll see later, it becomes more important with mechanisms like passkeys. So far, we've discussed the technology, but let's not forget that technology serves people, designed to make our lives easier. That brings us to the most important part of the authentication process: human actor. Have you ever waited particularly long for the loading icon after entering your credentials? Or maybe you didn't receive that 6-digit SMS code in time? Or simply found the login process painfully slow? These are all examples of poor user experience, which often leads to negative perceptions of a service. Users expect fast, reliable services with seamless, intuitive journeys. This as well applies to authentication. However, with authentication, there's an additional challenge: security. Unfortunately, security and usability don't always go hand in hand. Secure multi-step processes like multi-factor authentication often introduce friction, which can impact user experience and ultimately business outcomes. So the real question is, can we achieve both usability and security in the authentication process? Interestingly, this challenge isn't just technological. It also depends on factors like vendors, ecosystems, protocols, and most importantly, human behavior. Keeping in mind that authentication is a crucial decision point that can either grant or block access to a service and user expectations, the design of a perfect authentication flow becomes a real struggle. Take, for example, the common two-factor approach, where after entering your username and password, you're asked for SMS one-time password. I'm sure you've experienced this yourself. Not only do you need to remember a long password, but you also need to have your phone handy and within network coverage. If the SMS arrives in time, you then have to copy and paste the code. Clearly not a smooth user experience. Typically, adding more layers of security or advanced mechanisms decreases usability. However, significant progress has been made with FIDO2 and passkeys, which have shown that it's possible to improve both security and usability. One more thing to keep in mind is that security and usability can look different depending on who the user is. Let's dive into how these perspectives change. Is accessing your personal social media account the same as accessing an admin account in a production database? Is the risk of account compromise the same for your users as it is for your employees? I think we can all agree that the answer to both questions is no. When we talk about user types, we usually focus on employee and customer accounts, which have some key differences. For starters, employee accounts often come with higher risks because they access sensitive data and internal systems. But that's not the whole story. The number of users also plays a big role. Designing authentication for a few hundred employees is very different from setting it up for millions of social media users. The size of the user base impacts how smoothly you can manage authentication issues too. From a technical angle, there aren't many strict limits, but some authentication methods have requirements that can impact user adoption. For instance, push notifications need users to have a smartphone with an authenticator app, which might be easy for employees but harder for customers to manage. Similarly, passwordless methods might rely on hardware tokens, which can be practical for a small team but not for millions of users. Knowing these differences is key to building authentication that fits the unique needs and risks of each user group. Now that was a lot to cover. Let's do a quick recap. First, we looked at identification and authentication using a phone call example. Then we went over how communication between clients and servers works. We also talked about how usability and security can look different depending on the type of user. Now, we're ready to dive into some popular authentication methods and the potential threats users might face.